Okay, so let me first introduce myself. My name is Himanshi Singh, and I'm currently a PhD scholar at Department of Mathematics, IIT Jodhpur. And I will be your TA for this course. This course is Essentials of Data Science with R Software 2. Where we will be learning the theoretical aspects of statistics regarding the sampling theory and linear regression analysis, and we will be seeing its applicative side by using our software. So this is our first live session, and this course is, of course, taught by Professor Shalab, and I will be the TA for this course. And the live sessions, so we will be having the live sessions on every Monday. Okay, so we'll have 12 live sessions for the 12 weeks, and apart from that, we may also have some extra session if required. Okay, so it will be on every Monday and from 6 to 8 p.m. And if there is any change or something like that, so it will be informed to you by the NPTEL team. Okay, so apart from this, we will be so this is the Google Meet link. The first link is the Google Meet link from which you can join the session. Okay, and the second one is the YouTube link. So this is a channel link. That this is my channel link. So from I will be uploading all the recordings and all the things on this link, on this channel, and you can access it through this link. And all the R scripts which I'm like discussing here, and all these presentations and all these things, so it will be made available on this Google Drive link. Okay, so I've provided it here, so I will also just copy it. I will just paste it in this comment section, so you may access it from there. Okay, and so I will be so just try to open it. Then just let me know that you are able to access it, the folder of this Google Drive or not. Okay, and so yeah, so this will be the information. This is the information about the sessions. And if you are having any kind of confusion regarding the session or regarding accessing the material or all those things, so we will discuss it at the end of the session. You will just let me know, then I will be like taking those things. Okay, now apart from this, the plan for the live session will be like I will be first giving a brief recap about the topics which are covered in the week one lectures. So I will give a brief recap. Then, if some R demonstration is necessary, then we will be discussing all those things on R also. And if you have any doubt or something like that, so we will be discussing all together. Then we'll do some practice examples. Okay, so I want that you people also like just do the examples with me, because it will be, then the session will be a little interesting. Okay, so after that, the all the doubts regarding this session or the previous session or something like that, if there is something, then you may discuss it with me. Okay, so the duration will be for 2 hours, so from 6 to 8 we will be having this session. Okay, now if anyone have any doubt, then you may ask, then we'll just start the session. Any doubt regarding anything? So I'm hoping that you people have watched the week one lectures. So you have watched the week one lectures?
I just joined this course today, so I will watching continuously.
Okay, okay. So you have some like background, or so you have used this R before, or you have learned something about the this R language?
This is recently introduced in our BCom course final semester. So just to add on more emphasize on this, I just added from the SWAM portal.
Okay, so actually the thing is that for this course, I think little knowledge about the R is required. So in the first lectures, the first week lectures, the overall, so an overlook of how to use the R software, or what is basically the R language, how, what are the commands, basic commands which we can use in R. So this all things have been covered in this lectures, in this week one lectures. So you may get some help from here. So you're watching the lectures, and then you are also seeing these live sessions. Then it may be like useful for you to learn the R language first of all, but it is not like a detailed course on R, because if so it is required that you have some knowledge about R. Okay. Because after this lecture we will be using the R, and we are doing other things by using R. Okay. So however, we'll have a brief discussion today about what R is, what R software is, what the language is, how we can have this R software downloaded in the computer. And apart from that, we will be discussing some of the basic commands. Okay. Then we'll have some questions which will be helpful for you to solve the assignments which are there, which is there in the SWAM portal. So so let's start then. If anyone have some doubt or something like that, please ask. Then I will be starting the course, so the tutorial. Okay, so if there is nothing, then so please be interactive. If you have some doubt or something like that, please yeah, someone want to say something?
Ma'am, the recording will be available after some time for this
Yeah,
session.
so it will be available at most by tomorrow. So I will be uploading it. I will try to upload it by today only, because then it will be uploaded on YouTube by tomorrow. By tomorrow at max, or I will try to upload it today only. Okay, is it fine?
Yes, ma'am.
Okay. So then we will be starting this session. So, so first of all, what is our software basically? So if so you people are familiar with all these statistics we are doing in the subject. But what if theoretically we are doing the statistics, but wherever the computation and all those things, analysis of the data also it is required, then for that we cannot do all the things by hand. So to make that thing possible, we can use this R software. So it is basically we can use it for statistical computing, and also the graphical display of the data. The way So there are different commands, there are different ways to display a data. So that is basically R software or R language is a tool to how to understand the data by having a pictorial view of it. Or if there are some formulas or there are some concepts in statistics and we want to apply it on a data, so to make all that computations and all those things, basically we are using this R software. Okay. And R language is the language of it, on in which we will be like communicating with the software. Okay. So it is basically effective in data handling. R is a programming language. Okay. And it is an open source software. So you can download it, it is free of cost. And there are many packages, so it is basically designed for statistics. So other things also it can do, but the packages and all those things which are there present in R, so they are majorly designed for doing stats. Okay. So data are available there, so you can just take the data and do some analysis, whatever. So this is basically mainly designed for stats. Okay. So now how to download it? So if you want to download it, you can just go to this website, this www.rproject.org. You'll get this interface, and from there you just click on this download R. Okay. And then you will get this interface. So you can click any of the link. Okay. So this is so this I've clicked here. So this is cran.rproject.org. So this is basically the link for accessing this page. And if you click this any of this link, then you will get this page. So you can from here you can download R for Mac, R for Windows, whatever your system is. So you can just download it from here, and you will get it installed in your that computer. So this is the icon you will be having. So this is the icon you will be having, and whenever you will click it, and you will get the interface, and you will get the, you have to just code it there. So I will be showing all the codes, and those things will be there after some time. And now here I'm only discussing like how to download it. So apart from this R software, you also have one more software, I can say, that this is R Studio. So it is basically it is also designed for by using this R software, but this is kind of a software where some things are like easy, because compared to R. So if you are having heavy calculations, heavy, you need all the variables, you need all the things in a single screen and all those things. So it makes your analysis a little easier. So it basically, when you are doing a analysis, you want everything to be there. So this R Studio is a necessity for it, or not necessary, it is your choice, you can do it, you can just download it or not. So however, I will be using this R software only in through this course. Okay, so you can just download this R Studio from this proposit.co. Okay, this is the website. Then you will get this interface. From here, just click on this download R Studio. So you will get this interface. And from here, you can just tap on the link, whichever is like required for your system. Okay. So this is the way how to download it. I hope it is clear, like how to download this.
Yes, ma'am.
Okay, so how many of you have downloaded our software already? Okay. Okay, so yeah, so because if you are having some commands and all those things, so it is very necessary to download at least the R software and just take the command. So this, you have to yourself first explore the things by yourself. Like I'm here, I will be discussing some of the commands, but there are many more commands in R. Okay, I cannot discuss. I cannot maybe aware of every each and every command of the R, because it is a very like it is a very many things are there. So I'm here discussing only the basic things, so that we will in the after these sessions, whenever we are discussing all other things, the theoretical aspects of stats, then we will be able to do those things in R also by using these commands. Okay, so first of all, how to get help in R. So for example, you know some command, like you know sum. So sum basically, whenever we think of sum, so it is like it is we are summing two numbers. Okay, so this is the basic thing. It's that we are summing two numbers. But what is the command basically doing? Some command is doing in R. Okay, whether it is sum or whether it is add. So what it is basically is, so sum is a command in R. I'm giving you that information. So if you know that the command this is present in R, that is sum, then how to know that what basically it is about? Okay, so this is a help function. So help function is basically like you can do in two or two three ways to know about a function. So here you can put a question mark before sum, then you will get them. So here I have this. So here in the right hand side, so this is my console in the right hand side. Sorry, this is my here I'm writing the thing. So this is the script, R script, and here in the left hand side I'm having this console. Okay, so here I'm writing the commands, and in the left hand side it will be like executed. So it is written question mark sum. Okay, so I'm trying to know what basically the sum command is about. So whenever I'm just placing my cursor here in the first line, and I'm pressing command plus return. So here I'm having Mac, so I'm pressing command plus return. So then it will give me the output in the left hand side. It is like running in the left hand side, and I'm getting this information. So this is sum. So what is the usage of sum, what it contains basically. So all the details are there present, what is like relevant to this command sum. Okay, So this is the way I can get some information. So for example, mean, we know what mean is, so we are averaging the numbers, basically it is about that. So if you want to know that what basically in R, how, what is the syntax of it, what all these things are there, so if you know, so uh, this is giving me that information. Okay. Okay, now apart from this, we have this help function. So help, in help, and I'm writing this double quote sum. So if I do that, so here again, I'm getting the same output. Okay, so these are the some of the commands, and this is also the help dot search also is a way to find out. So for example, if in place of sum, if I write help add, okay, so what it will give, so it is giving me in the left hand side that no documentation is there for add. So basically what happened is that add is not available in the, so add is not is available in the language of R. Okay, so there is no command called add in R, so that's why it is showing me this error. So if I want to search something by a topic name, okay, then I have to use this help dot search. So if I do that, then it will give me this interface, and from there I may get some help about this add thing. Okay, so these are the very basic things I'm talking about here. Okay, apart from this, there is a function called this example. Okay, if you want to see worked examples about something, okay, so for that, so for example, I have this command sum with me. Okay, and if I want to see the some example, some worked example about sum, so then I will write example, and this in the curve brackets I will having this sum. So here if I do that, okay, so someone is asking, posit is an organization. uh, so actually this cran is a something there where you have all the R packages and all those things. Then I don't know, I don't have that much knowledge about whether posit is an organization or not. So yeah, so here if I write example sum, then it is giving me the result that I'm passing. So here in the left hand side is giving me an example about if I pass a vector 1 to 5. So basically I will be telling about that what basically 1 colon 5 is. So here I'm just telling about this example command. So it is basically summing all the numbers from 1 to 5, and it is giving the output 15. So basically it is giving me an example. So how to get an example in R to see the work example about sum, I can just write this example sum. Okay, now apart from this we have packages in R. Okay, so there are many packages available already in R, and there are some packages we need to install. Okay, so if there is some function I want to use and which is not available in the packages which are available in the R, so then I need to install some packages, and I need to call that package again, and then I can use the functions which are present there in the package. Okay, so if you want to see that what are the packages which are available already in your system, the art software, then you can just uh, write this installed dot packages. So if you run it, so you'll get the all the packages here. So all the packages which are available in R. So for example, this base, this crayon, crosstalk, so these are all the packages which have some functions. So for example, sum is a function here, and sum is a function which is available in some of the packages. Okay, then only we are able to use the sum function here directly. We do not need to write all the things together and write plus sign in between. So basically we use the sum function, and inside the bracket we'll just give the values and it will sum it up. Okay, so but this sum function is available in some of the packages, then only we are able to use it. Okay, so apart from some functions, there are many more functions which are available in different packages. But in order to see that what are the packages available with us, we can write this command install dot packages. Okay, but in case we want to install some new package, like I have some knowledge like this function is available in that package, but I do not have that package, so I have to install that package in my R. So for that I need to use this command install dot packages. Okay, so for example I have written this data dot table in the, so this data dot table is a package. Okay, so here we have written this install dot package. Whenever I run it, so in the left hand side I got this that please select a cran mirror for use. So any mirror I can select, so I am just selecting it. Okay, so then by selecting it will be installed here. Okay, so it will take a little time, then it will get installed. Then after getting installed, okay, after getting installed, I need to call that package in order to use the function present inside it. Okay, so here it is executing and it is downloaded. Okay, so it is already downloaded. Now if I want to use some function from this package, then I have to call that package. Now in order to call that library or a package, then I need to use this library, and in the parenthesis I need to write this data dot table. You may also write it without this curly this inverted commas, that's fine. Okay, so here data dot table, I've called the data dot table. Now I can use this any functions which is present in this package uh, whenever I want to do. But once I just quit this R session, then again I do not have to install the package because it is installed already, but I have to call the package. So basically I have to write library data dot table. Okay, so this is the way I can just install the package and I can call the package in order to use the functions which are present inside that package. Okay, now I want to know about know something about the package, that what the package is about and all those things. Then I can write this package description, and in the parentheses I can write the name of the package. Then it will give me the package description. Okay, so I'm just talking that what this basically these commands are meant though. So whatever present in this data dot table is there in the left hand side. So this is the description about the package. Okay, and apart from this also I can get the help by using the help I can also get some knowledge about this package, that is library help is equals to data dot table. So it will also give me some of the information about this package data dot table. Okay, so this is basically the description of the package. It is having that the authors, the persons, and all these things about this data dot table. Okay, title and the uh, license URL and all those things. Okay, so this is basically this command is giving. So it is basically telling you that what data dot table package is about. Okay, so apart from this, if some package you need and you want description of that package, you just have to install it and write that name here and get the information about it. Okay, so this is about the packages and libraries in R. Okay, now our first question will be that how to perform the operations here in the R. So basically, if you have digits, then you can just write it like 2 plus 5, you just write it. So we are adding just 2 plus 5, and you are getting in the left hand side the output as 7. Okay, here powers, if you're writing, so 2 to the power minus 5, I'm writing. So I'm getting the output in the left hand side. Similarly I can do the power by 1 by 5. So it is basically the basic calculation which we you also use as a when we are using the calculator also, you are just doing that thing only. Okay, apart from that, what new is here is that we can also have some variable, and we can assign that a value to that variable, and we can perform the calculation with that variable, and at the end I can get the result as a variable. So basically, so here I have assigned this to, so basically this is the assignment operator. So this is the assignment operator, which is this less than mark and by followed by a dash. Okay, so I'm assigning a value 2 to x. Okay, and here I'm assigning, so I can also assign it in this way. Okay, both are fine. In this way also I can assign, but I cannot. So I'm assigning 2 to x. So this hat thing should be towards the variable, not towards the number. Okay, we can reverse it, but we cannot do, so we cannot do like this. So here if I have y, and I cannot do like this. So this is not the way. Okay, this pointed thing should be towards the variable. Okay, so so here I'm assigning value 2 to x, 5 to y, and then I'm just finding out x to the power y. So what is the use of it? So here what I can do, I can just change the value of x and y and find out uh, the power. So for example, I can change the value 2 to 3 and 5 to 7 or something, and I can again store those values in the a different variable zp. Okay, so if I run it, so x is now 2 is stored in x. Okay, 5 is stored in y. So what will be zp? So zp is x to the power y. But for that I have to write here zp in order to see that what is the value of zp basically. So in the left hand side I'm writing zp, and if I see, so it is 32. Okay, so 2 to the power 5 I'm getting it as a 32. Okay, so is it fine? Is there any confusion? Is it fine?
Yes, ma'am.
Okay, so then there is another command like C. We can use it to combine the numbers. Okay, so if I have different numbers like 1, 2, 3, 4, 5, and want to make it as a vector, okay, so this C command is used to make it as a vector. So then we can have, like, now till now we had only one number. Now we can have a vector which contains a number of finite length. So the length of the vector should be finite, otherwise you can give the numbers to each of the position and you will have a vector. You can have two vectors, you can perform operations between two vectors also. Okay, you can have addition between two vectors, you can have multiplication towards between two vectors. Okay, so now this is increased to more than one dimension. Now what about this is also a command rm. This rm command is used to remove some variables. So for example, you have given this x and y some value 2 and 5, and but you want to remove these variables, okay, from your this console part. Then you can just write rm x comma y, so it will remove x and y. Now if I write here in the left hand side x, so it will give me an error that this x is not found because I have already removed these x and y. So if you want to remove that, then you can just do this. Okay, so also this to combine numbers, let me run it. So I'm getting this m here. If I see that what m is basically, so it is 1 2 3 4 5. So I'm getting m to be a vector of length 5. Fine. So in mathematics, when we talk about numbers, first we have talked about numbers. So then we talk about vectors. Then we talk about matrices. Okay. So now we have also the concept of matrices. So this is basically I've talked about already, that addition, subtraction, multiplication, division, power. We can do all these things between two numbers, multiple numbers, also between two data vectors or multiple data vectors. Okay. And apart from this, also R follows this Bodmas rule. So all of you know about the Bodmas rule because we will be having some questions on that. So you know about Bodmas rule?
Yes, ma'am.
Okay, so basically R will be following the Bodmas rule, whether we are doing the operations between two numbers or whether we are doing operations between the two vectors, two data vectors. Okay, so it will be following the Bodmas rule. Also, apart from this, we have functions like max, min. So basically, we have some function. So for example, here, if I have this, I have this. So for example, I have this m to be a data vector. So if I write sum m, okay, so what it will give? It will just give me all the values. So the sum of all the values here present here. So it will give me. So here in the left hand side is giving me 15. Okay, apart from getting a vector like this, I also have another option. So for example, let me show you that m1, and I want like consecutive numbers. So these are consecutive numbers. We also can have a data vector where numbers are not consecutive. But if numbers are consecutive, then you can skip writing all the numbers. You can just write 1 colon 5. So you'll get all the numbers between 1 and 5, including 1 and 5. Okay, so here m1 is also this data vector. So if I write m1 here, then also I'm getting the same data vector. 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. So M and M1 both are same. Okay, so whenever you want to write a consecutive number from 1 to 100, you need not to write everything from 1, 2, 3, 4 to 100. You only just write 1 colon 100, and you will get all the numbers as a data vector be stored in this variable. Okay, and sum is a function. Apart from sum, we have many functions like max. It will give you the maximum of the values in the data vector. Okay, min will be give the minimum, mean will be giving you the average value, abs will be giving you the absolute value. So if you have a data vector which consists of -2 and 5, so absolute will give you 2, 5. Okay, so it is basically neutralizing the effect of negativity. And sqrt is a function which is used to find the square root. Round is used to round off. Median is used to find out the median of a data vector. Apart from that, we have floor function, ceiling function. So you guys know about floor function, ceiling function? So you may get some question. That's why I'm interested to discuss this, because so if you have like this 3.5, so this is basically the notation for the floor function. So this is the floor function. Okay, so floor function, what it do, it just give you the number which is, so for example, I'll get 3 as an output. So it is the integer which is less than 3.5. So it will give you the integer as an output. Okay, ceiling function, what it will give, so if I have the ceiling 3.5, so this is the ceiling function. So it will give you the number which is just greater than 3.5, integer which is just greater than 3.5, which is 4. So this is the difference between this floor and ceiling. And round have different thing. So round off, when we are rounding off, the mechanism is a little different. But when we are writing the floor function and ceiling function, so it is giving you the integer which is just less than the present integer in the argument. And ceiling function will be the greater integer. Okay, is it clear?
That same task is also done in round function, I think so, ma'am.
No, yeah, for 3.5 it will be the same. Okay, fine. I'll just take another example. So for example, if it is 3.6 here, okay, and okay, let me just give you another example. So if it is 3.6 here, okay, and if it is 3.2 here, so round off will give you 3.6 to 4, it will give you 4. 3.2 it will give you, round off will be giving you 3. But the floor function, again, here also it will give you 3 only. And for the ceiling function also it will give you 4.
Yeah, ma'am, thank you.
Yeah. So that is the difference. Now, some function is there, product function. So it is product function. So it is basically used to find out the product of the numbers present in the data vector. Apart from this, we have this exponential function, log functions, and we have many more, like trigonometric functions are also there. So I've not included that here because you may get that by using the like help thing or something. So there are like sine is also there, cos is also there. So those functions are also here present. Okay, so you may use that also. Now these are the mathematical operations. So I have not included any code for that because so it is understood. Or apart from that, we will also be discussing some of the questions on these functions as well as on these operations. So we'll discuss the things from there. Okay. Okay, so apart from that, now we have matrices. So if I want a matrix, for example, here, so I hope that you know what matrix is. So it is m rows and n columns. So if I have a matrix like this and I have numbers, so if I want a matrix in R, okay, so the syntax for that matrix, in order to generate or in order to create a matrix, I have to write this command. So here x is a variable. I'm assigning a matrix to it. Okay. Here I'm writing n row to be equals to m. So in place of m, you may write some number, whatever number you want. It should be positive, and n call to be n. Okay, and data. So you will be giving data here. So what it basically is, so n row, the number here, so it will be the number of rows, n will be the number of columns, and the data will be the data we want to input in the entries. Okay, now how the data will be entered? So it will, by default, it will be entered by columns. So it will be the first entry will be here. Okay, second will be here, third will be here, fourth will be here, here. So it will be entered like this. Now if you want to enter, so this is the first entry, this is the second, third, fourth entry of a data vector I'm talking about, of this data vector. But if you want to enter it like 1 2 3 4 in this way, so here I'm talking about the entries. So then you have to write this by row to be equals to true, then it will be added by row. Okay. Now, between two matrices also we can perform operations, only on the condition that the dimensions of the matrix should be same. If you want to perform plus minus a multiplication or division between two matrices, the dimensions of those two matrices or three matrices should be same. It should not be different. Okay. However, for the matrix multiplication, we have another rule. So the number, so here if I have a matrix like 1, 2, 3, 4, 5, 6. So for the matrix multiplication, I need that this, so there are three columns we have. So if I have three columns, I should have three rows here. Okay, so for that I need 2 1 5 6 7 8. So this is basic rule for the matrix multiplication. So what we do, we just this 1 into 2 we'll do, plus 2 into 5 we'll do, plus 3 into 7 we'll do. So this is a so there are number of rows is 2 cross 3 matrix. Okay, and this is 3 cross 2 matrix. Okay, so we'll get a 2 cross 2 matrix after the matrix multiplication. Now for this multiplication, we need this operation, this operator, basically percentage sign, star and percentage sign. This is for the matrix multiplication. And for the transpose of the matrix, we just write Tx. Okay, so it will give me the transpose. I hope you know about this, that what transpose of a matrix is.
Yeah, ma'am.
Yes, ma'am.
Okay, so now how to access. So let me show you first of all how to create a matrix. So here I've created a matrix M1. So here I have two rows, two columns, and I'm giving you the data vector from 1 to 4. So basically I want 1 2 3 4 entries to be there present in the matrix. So if I run it, so I'm getting a matrix here M1. If I see, so I'm getting here this matrix. Okay, so now you can see that by default the entries I'm getting 1 2 3 4. So it is column wise entries. Now if I want it row wise, then I have to write by row to be true, and here M2 is a matrix which I have done in that way. So here if I see that M2, so if I write M2 here, then I'm getting in this way. So I'm getting the entries row wise. Now if I'm doing M1 to the power M2, so I am performing this power operation between two matrices. So how basically it is getting performed, that first element to the power first element, second element to the power, sorry, the element at the position first row second column is will be, so 3 to the power 2 will be happening, 2 to the power 3 will be happening, 4 to the power 4 will be happening. So basically the numbers on the same position will be operated by this operation to the power. Okay.
Ma'am, how to change the default values? Here 1 to 4, right?
So if here, if you want to change it, so you want some other data vector to be entered. So what do you want?
Actually, the numbers is 1, 2, 3, 4, right, ma'am? How
Yeah.
to change those numbers?
So then you have to construct a different matrix, or you can change it here also. So for example, I want some other entry. So basically I need four numbers to be entered. Okay. So I will write a data vector here then. So what numbers I want? For example, I want 4, 6, 9, 2.
You need to
Okay.
take a C combine operation.
Yeah, by using this combine operation. So basically I'm giving a data vector. Now how the way to construct a data vector are different. So you can use this C option also for that, and if you want consecutive digits, then you can use this operation also. Okay, you want a data vector to be inputted in this place. Is it fine?
Yeah, ma'am. Thank you so much.
Yeah. So now if I'm getting, so here in the left hand side I'll get a different matrix, 4 6 9 2. Okay, now if I'm doing m1 to the power m2, so then it will give me 4 81 216 16. So basically what is happening, 4 here I have this 4 and 4 to the power 1, 9 to the power 2, 6 to the power 3 and 2 to the power 4, and I'm getting this matrix. So element at the same positions are getting operated. Fine. But if I want to do a matrix multiplication, okay, the way which I talked about, so then I will use this operator and I'm getting this matrix. Okay, if I do simple multiplication, then each entry will get operated by itself. So here if I do m1 star m2, then what will happen? 4 into 4 will be there, 9 into 81 will be there. So each element at the same entry will get operated. But in order to do the matrix multiplication, I should use this. Now, how to access an element? So here I'm talking about all those things, but in the questions I want you to answer. So please, like listen carefully. So then you will be answering the question, and it will be good for you also to like get all the things revised. Fine. Now, if I want to access the element which is present at first row and second column of a matrix. So this is a M1 matrix, this matrix. So the first element, first row and second column, the element is this 9. And if I want to access it, so I'll just write that I want first row and second column inside and square bracket. Okay, so then I will be getting this element. So if I run it, so I'm getting this 9, so which is present at first row and second column. Okay, now if I want a row or a column, so if I want, for example, second row of a matrix, so this M2 is a matrix this, and if I want the second row of it, this row, so I'll just write at first place 2 and at second place I will leave it blank. So then it will give me the second row. Okay, so this is the way how to access an element. So here I have also included other options. So here I want to access it, then it will be like this. I write the ith row, jth column, I will get an element. But if I want ith row to be accessed, then I have to write I or whatever number you want, whichever row you want. So you'll write just, and second place you will just leave it empty. And if you want jth column, then you will just take first argument to be empty, and you will just take j to be the whatever column you want to access. Okay. Now, for example, you want to access a sub matrix. For example, if you have this matrix 2, 5, 6, 7, 8, 9. Now, if you want to access this matrix, for example, this submatrix, so basically you want rows, the first and second rows and first and second columns. So what you write, so you will write just 1 to 2, okay, comma 1 to 2. So it will basically give you the rows from 1 to 2, so that is this row and this row, and 1 to 2 columns, so this column, this column. So it will give you this sub matrix. Now for example, you want the first this thing and this thing, so then you have to write x. Now these are not consecutive. First I want first column and third column, and first row and second row. So I want first row, second row, so it will be same. But if I want first column and third column, so I'll write it here C 1 comma 3. Okay, so then it will give me the first to second row, so that is this row and this row, and first and third columns. This is column, this column. So it will give me 2, 6, 7, 9. So this is the way I can access a sub matrix from a matrix. Okay. So here I have not included an example for this. So is it fine, or should I do this also in R in coding? So are you people getting these things? Anyone? Is there any doubt or something? Okay. Okay, so this was about the matrix. And now if I talk about, so if I want to repeat, so for example, I want to make this pattern like 1 2 3 1 2 3. So basically I'm repeating the same data vector again and again. 1 2 3 data vector I'm repeating again and again. Or I want 1 1 2 2 3 3, something like that. If I want these type of patterns, then I have this command rep, and inside that I will write a data vector x and times is equals to n. So this basically means that this data vector will be repeated n times. So for this, so I have this rep, and here I have this data vector 1 2 3, and I have to repeat it, for example, 3 times. So it will this command will give me this pattern. Okay, but if I want each element to be repeated 2 times, then I will write this command rep, and I want each entry to be repeated. So I will write each is equals to n. So n will be like, for example, if I write 2 here, then each entry will be repeated 2 times, 1 1 2 2 and 3 3. So it will give me this. Fine. Apart from this, if I want to compare two numbers, for example, I want a comparison between 2 and 3. So if I want to compare these numbers, that this is greater than is equals to or not. So if for all those operations, these operation this operator greater than equals to, less than equals to and not equals to and not. So these operators are used, okay, in order to compare two digits, or in order to compare two data vectors also. Okay, now if I have a data vector, and if there is like, if there some missing quantities are there, so for example na is present at the second position of a data vector, then how to detect it and how to do the operation in the presence of such quantities in a data vector. So for that, this function na.rm is equals to true is used. So if I want to do this, for example, this is x, and if I want to sum the elements, so if I want to do sum of x, so it will return me na because na is present here. Okay, but if I write in the argument na.rm is equals to true, then it will be returning me. So for example, if I write sum x comma na.rm is equals to true, so for that case it will return me what it will return. It will add these number 4 5 6 7 8 9, so it will return 9. Okay, so how to handle a missing data value? So you have to write this na.rm is equals to true. So it will just this eliminate this na from the data vector and do the operation on the other numerical values. Fine. So yeah, so here I have included this replication. So for example, here I have included a different thing. So for example, I have included a rep C123 C123, for example, and if I run it, so you are getting this kind of a pattern. So what basically it is happening, that 1 is repeated 1 time, 2 is repeated 2 times, 3 is repeated 3 times. So second argument is about the times. First argument is what we need to repeat basically. So it is giving me such kind of an output. Okay. Okay. If vector contains missing value, then I have taken this vector, and in order to see that whether it have a missing value, I have to write is.nav. So it is giving false at first position, false at second position, and true at third position, at false at fourth position. So basically it is saying that at third position there is some missing value. Okay, if I do sum of v, so it will give me na because na is present. But if I write na.rm is equals to true, then it is giving me the answer 21. So which is the sum of the numerical values present. Okay. Apart from that, we also have a way to store the values, that is data frame. It also have its own advantages to use a frame apart from a matrix or a or different ways which we can use which are used to store data values. So this is also a way to store the values or to combine the data. And the if I have x data vector, y is a data vector, z is a data vector, then if I want to combine in a single data frame, I can say, or in a single list, I can say, then I can use this data frame. But for this, the lengths of this x y z should be same. They may not be they cannot be different. Okay, so lengths should be same. Now what is the syntax for it? So you just need to write data dot frame x comma y, where x and y are data vectors of same length. Okay, then it will give you a data frame, or it will give you a combination of those data. Then what you can do, you can use that data also. If you want to access some particular elements of that data frame, then you can access. And So this is also a way to combine it. Yeah? So if I show you some of the commands, so here I have taken these three vectors x, y, z. Okay, I've stored it here. Now if I construct a data frame, so how it will look like, so let me show you. So df will be this. So this is x, this is y, this is z. X is a first row, y is a, sorry, first column, y is a first column, second column, z is a third column. Now these are the columns. Now if I want to, for example, if I want to access something, or I want a subset of it, okay, then what I'll do, I'll just write this command subset. Inside it I will write a df, which I have assigned already to that data frame. Then if I can, if I impose that x is greater than 23, okay, so basically it will be displaying all the values of x for all x, y, z which are greater than 23. Okay, so here it x greater than 23 is 29, 40, and 29 again, 34. Only these four values, four five values. But here also I have written, apart from this I have written select is equals to c minus 1 minus 3. So this is a data vector basically. What it is basically doing, that minus 1 means that first row, sorry, first column is eliminated. Minus 3 is saying that third column is eliminated. Okay, so it will only give you the second column. Okay, and second column, what are the elements it will be giving you for which the x is greater than 23? So position for which x is greater than 23. So x is greater than 23 for the third position, so it will give you 17. And x is greater than 23 for fourth position, so it will give you 29. Okay, these are not greater than 20, 23. 29 is greater, so it will give you 17, and 34 is greater, so 39, 38. So these value of y will be given because x and z are eliminated already. So let me show you this. So it is giving me this 17, 29, 17, 38. So for which the x is greater than 23. So only that values are displayed here. Fine. And if I want to access the second column, then I can also write df$y. So y is the column name. So I'm writing df$y. So here it is giving me the y column. So this is the way I can access a column of a data vector. So for example, I have a data and I want to store that data in a data frame, but I want to operate on a single column of that data vector. I do not want each and every data vector to be operated by something. I want only a single column to be operated. So for that, first I have to access that column, then I have to uh, put some operation on that. So how to access that column or particular entry of a data frame? This is the way, by $sign you can do that. Fine. So apart from that, we have this graphics. So graphics is about how to get a pictorial view. So for example, I have this already the vectors, data vectors with me. If I want to plot it, so it will give me a scatter plot between two data vectors x and y. So if I do that, so here I'm getting a scatter plot. And I can also use different type here to get a different pictorial view. So for example, if I write type to be equal to h, okay, then it will give me this type, this histogram type of view. Okay, apart from that, if I have three data vectors, and if I want to combine all these things together and see the graphs, then I can do this command pairs c bind xyz, so I'll get this view. So sir has already taught these things, I'm just recalling those things. And also if I want correlation between these, like I want to know the degree of correlation between these three data vectors, between x, y, y, z, x, z. Okay, so then for that I need these commands. So for that I need, for these commands, actually this is not present in the base package of R. So for that I have to install this package core plot. Okay, so install.package, if I do, so I'm getting this. If I install this package, so here it is getting installed, okay, in the left hand side. And then I have to call the library to use this function cor and core plot. So I'll just call the library using this library command. Then for this function to be used, our data vector should be combined as a data frame. So I'll just combine these xyz data vectors as a data frame. So I'm getting this xyz as a data frame. Now in the argument of core I will write the data frame, and I'll get, so xyz underscore call, so it will give me um the correlation table, basically table kind of. So here this is a correlation between xx, xy, xz, yz, correlation coefficient between these two data vectors. Okay. So basically they are talking about the linear correlationship between two data vectors. Fine. Now if I want to have a pictorial view of it, so I'll write the score plot. So this will give me this thing. Okay, here I'm using method to be number. That's why it is giving me numbers. If I use different methods, for example, if I use square here, if I use square here, then I'll get a different pictorial view. So it is basically telling me, the dark color is telling me the relationship is very, very, like it is a maximum relationship. Okay, light color is telling me that the relationship is little light. The degree of relationship is decreasing whenever the color is becoming light, and also the shape of the square is decreasing. Okay, so these are the ways I can have the view of a relationship, a linear relationship between two or three data vectors. Fine. So this is about the topics which are covered. So if anyone have some doubt, then you may ask. Then we will move towards the questions. So I've tried actually to cover everything, every command, so that I can have a, like, you people have some of the insights using the art. Then we will have some questions. So anyone, if you have doubt, then you may ask.
Ma'am, how to create a subset from a matrix? My internet
From
is
a
trouble in that turn during that time.
Okay, okay. So here I had a matrix. So let me take another matrix only. So in the console only I'll write. So here I am taking this matrix M, for example, and I'm constructing a matrix. Uh, so n row and rows I'm taking to be, I'm taking a big matrix 4, a little big, n call to be equals to 5. So I'm taking a 4 cross 5 matrix. Okay, so the element should be 1 to, so 20 elements should be there. So I'm writing just 1 to 20. So it will give me a matrix. So this is the matrix. Now, for example, so which sub matrix you want? Just tell me. I'll just let you know that how to do it. So which columns you want, which rows you want. So okay, okay,
3
okay.
and 2, column 3 and row number 2,
Column you want third column. Okay, this
and row
column
2. Yeah, ma'am.
and row two. So basically, you want this 10 element to be there, no? Only 10, only 10, 10 will come. It will not give you a sub matrix. So you want third row and second row and third column. So second row and third column will have intersection at 10. So it will give you 10. So just let me write it first. So this matrix is M, and I want third row, sorry, second row. Okay, so you write the row number at the first place and third column. So you will get 10 only by giving only this information. So you have to have a matrix. Now for matrix, you should so for example, you want this sub matrix 6, 7, 10, 11. If you want this, okay, so for this you just find out the intersections. So it is at second row, 7, 11 is at third row. So here you can write C, second row and third row, 2, 3. And what are the columns involved? Second column and third column. So you just write at the column 2 comma 3. So you will get this matrix 6, 7, 10, 11. Okay, now these are the consecutive ones. For example, you want 5, 8, 13, 16. Okay, so 5, 8, 13, 16 involves which rows? First row and fourth row. So you just write C 1 comma 4. Okay, and 1 comma 4, and you want 5, 17. So if second column is involved, fifth column is involved. So here you write 2 comma 5. So then it will give you 5, 17, 8, 20. So you just see that what are the rows involved, just write those numbers, and what are the columns involved, write those numbers, then you will get that submatrix. Is it fine?
Yeah, ma'am. Yeah, ma'am. Thank you. Thank you.
Okay. Anything else? If someone wants to ask, then we'll just go towards the questions. Okay, so we'll go towards the questions, but I want you people to answer those questions. Okay, right or wrong, just answer the questions to make this session to be a little interactive. Okay, so here I have this first question. Write commands in R to evaluate the following equations for different variables x and y. So we have variable x and y. Okay, whatever the values we'll give it, we will give it in R. Whatever value we will give. First of all, you have to evaluate these expressions. So for these expressions to be evaluated, we need to write these expressions in R. So how one should write these expressions? You cannot write it directly. So how one should write these expressions? So I'm writing for the first one, and for the second one, I'll ask you people to write. Okay. So this is x square basically. So for the power, I need to the power thing. So x to the power 2 plus y to the power 2. And now I want it to be divided by x plus y. So I'll just first separate it by using a bracket. Then I will write division thing. Then I will write x plus y. So why I'm using these brackets? Because if I do not use this bracket, for example, then y square. So for example, if I write x square, uh, so if I write x to the power 2 plus y to the power 2 divided by x plus y. For example, if I write this, then by using the Bodmas rule, it will be evaluated first, then other things will happen. So I do not want, because I want the whole thing to be divided by x plus y. So that's why I'm separating them by using the bracket. So you have to be very very like you should um, think about these things, that what is basically the expressions and what are the commands you are giving in R. Okay, so this is the way I should write in R to get the output for this equation. Is it fine? Is it fine? R follows Bodmas rule. Bodmas everyone is familiar of. So it is bracket. So this is order. This is division. This is multiplication. This is addition, and this is subtraction. So in this way, the operations are done. So first of all, bracket will be solved, then order means the powers, then division, then multiplication, then addition, then subtraction. So that's why I have to write this way. So is it fine? And if it is fine, then please just answer for the second one. And please use the function commands. Okay, so for the square root, I told you that sqrt function is used. So just use that sqrt command and just tell me that how to write this thing in R to get the output.
SQRT bracket x power 2 plus y power bracket 1 by 3
X to the power 2 plus
y
y.
power. I can make a bracket.
Yeah, y to the power. Yeah. So y to the power 1 by 3. This way. So you can take the bracket here also, but you can, if you do not take it, then also it is fine. There is no problem. So this, and if you write in this way, x to the power 2 plus y to the power 1 by 3. In this way, this is also fine. Okay, because 1 by 3 will be evaluated first, then powers will be evaluated, then we'll do the addition. Okay, so yeah, so someone has written in the comment box also, so that is also fine. So that is a different way to write it. So so it's like s so you have used the sqrt of uh, you have not written the square thing, no, x square. So it is not the square root of x, it is x square. So you have to write sqrt in in the first function as a sqrt. Then inside this you have to write x square plus y by 3. And if you do not want to write sqrt, you want to write 1 by 2 there, then you can write it like x square plus y to the power 1 by 3 here, and at the whole you can write this to the power 1 by 2 in this way also. Fine. And apart from this also, as you have written the comment box, this can be used, or this double star can also be used. So both of them are having same functionalities, this to the power. So double star also do the power of a number or a variable. So these three syntaxes are fine. You can you will get the same output using all three. So is it fine, everyone?
Yeah, ma'am. Ma'am, a small doubt.
Yeah.
Whether recorded videos is available?
So it will be available on the YouTube, and the link is there present in this slides. Okay, so here I have given the link, and the link for this Google Drive I have pasted there in the comment box, so you can get the Google Drive link from there. If you want, I can also give the YouTube link in the chat box also. Okay, so I'll just give it. So these with the recordings will be available there in this channel, on this channel. Okay.
Ma'am, and what about PPTs?
It will be on the Google Drive. The link to that I have already pasted on the chat
Okay, ma'am.
box, in the chat
Yeah,
box.
ma'am.
Okay.
Thank you, thank you. I didn't get
Okay.
it.
Fine. So this is done. Now we'll move towards the second question. So here I want output for this command. So if people just the give the output. So basically I'm assigning a value to a variable z, I'm assigning a value to a variable x, and I want that what will be the value of x. So what will be the output for this? Or you can just give your answers in the chat box also. So what will be the value of x, whether it will be a vector or it will be a scalar or what, and what will be the value of it? Yeah, so it will be a vector, because yeah, because at the first z we are adding 5 to a vector, so it will return a vector. Then we are multiplying 8 to that vector, so it will again return a vector. So what will be that vector? So this is adding, we are adding this vector to 5 to this vector, so it will give me, so 5 will be added here. Yeah, okay, someone answered. So okay, 7. So it will give me 7. 4 plus 5, 9. And it will give me 7 plus 5, 12. And 9 plus 5 will be 14. And then, so this z is stored here. Then here I am just multiplying by this vector by 8. Okay, so it will be 56, 72, and this is 96. Yeah, so two people have answered, 112. So the output for this will be this thing. Fine. So here what we are doing, we are adding a number, a scalar to a vector. We are multiplying a scalar to a vector. Okay, so these are the operations between a scalar and a data vector. Fine. Okay, so just do one more. So this double star is nothing but it is to the power. So it is, they are same. Okay. So 2 to the power 2 is 4 and 2 double star 2 if I write. So this is a different way to write it. So it is also 4. So just evaluate it and just remember that we are following the Bodmas rule. Then just evaluate. Okay. Follow the Bodmas rule. So in the Bodmas rule we have this bracket is there, but there is no operations in the bracket, so we are not there is nothing to evaluate for that. We have O, so we have order, so we have power here. So first of all power will be evaluated, so this will be there. So other things will be as it is, this and this. So answer one answer is there, so that 26, 25. So I have two different answers now, 25 and 26. Okay, so let me check. So this is 3 to the power 2, so it is 9 here, plus 5 to the power 2, so it is 25 here. Okay, plus I have this as a this is the negative square root of 4, so this is like so it is 1 by root 4, so it is 1 by 2, so it is 0.5, right? Plus this we have done because we are power is there. Okay, 26 plus 1 by 2 minus 9. Now this is so let me write it as it is, then the next step I'll do. Fine. Now I have plus and I have division. So first of all division will be there. Okay, so I'll just operate this. So 0.5 will come here, 0.5 here, other things as it is. Just writing it minus 9. So 9 and 9 will get cancelled. This is 0.5, this is 0.5. It will be 1. 25 plus 1, so it will be 26. So yeah, 26 is correct. So here we are following the Bodmas rule, and for that we are just so first of all we are evaluating the powers. Three places we have powers, so we are evaluating the powers. Then we are dividing, operating the division. Then at last we are operating the addition. Is it fine? Any doubt in this?
No, ma'am.
Okay. So then just write the output for this also. So we are okay. So one thing I want to tell you, sir have taught it in the class. Is I want to make you remind that if I am having two data vectors, for example, 2, 5, 6. Okay, this is a data vector plus 2, 3. This is a data vector. So this is of length 3, this is of length 2. Then what will be done if I'm adding these type of data vectors? Then 2 will be added to 2, so it will give me 4. 5 will be added to 3, it will give me 8. But 6 will be added to what? So again it will be added to 2. So it will repeat itself. The second vector of length, shorter length, it will repeat itself, and this 2 will again be added to 6, so it will be 8. So some same thing will be happening with every operation. If there is a vector of shorter length, then it will repeat itself to get added by the remaining values of the data vector of length, of more length. Fine. So this thing you will be using here in this division. That's why I'm telling you, because this is of length 4 vector and I'm dividing it by length 2 vector. That's why 5 will be divided by 15 will be divided by 5, 12 will be divided by 6. Now 25 again will be divided by 5, 18 again will be divided by 6. Fine. So 5 or 6 repeated itself once. So just do this thing and just tell me what will be the answer for this. So here also we will be following the Bodmas rule. Okay, so this the power will be operated first. So it is 4 to the power 1, 6 to the power 2, 8 to the power 3 and 2 to the power 0. Fine. So the first operation will give me 4, 36 and 8 to the power 3. What would be the 8 to the power 3? Let me check. 8 to the power 3 is 512. So it is 512 at the third place, and 2 to the power 0, so that will be 1. Okay, so I have evaluated the power thing, then the plus is there, minus, okay, so minus, so now I will operate the division then, sorry, yes, the division, so it will be 5, so it will be C, 5, this is 3, 6, 12 by 6, so it is 2, again 25 by 5, so it will be 5, 18 by 6, so it will be 3. Okay, then we'll subtract it here, or we can add it first. So this is 14, okay, and this is 41, and this is plus 7, 519, this is 10, minus this thing. So 14 minus 3, so it will be 11. 41 minus 2, so it will be 39, yes. And 519 minus 5, so it will be 514. 10 minus 3, it will be 7. Yeah, correct. So, yeah, your answer is correct. 11, 39, 514, 7. Yeah, correct. So, we are following here the Bodmas rule again, and we are doing it this way. So, is it fine? We are just following the Bodmas rule, and the thing that if I have a greater data vector and a smaller data vector, then the smaller will repeat itself to do the operations. Fine. I have one more question which is similar. Okay, so here I have functions. Fine. So I will be using here the Bodmas rule as well as the functions which is there present in the R. Fine. So here I'm using this maximum function, square root function, minimum function, absolute function. So if I want to evaluate this thing, again, first of all, I have to solve the brackets. I have to then find out the values inside what the function is giving me the output, then finally the final value. Always just remember that you have to follow the Bodmas rule. So in this bracket, the first bracket, so this is the first bracket, this is the first bracket here. Now inside this max command or function, we have these data vectors. Here we have this division. So we will first operate the division. So the first data vector here will be same 15279 minus, we'll have this division. So this is 2 by 1, so it will be 2 only. So it will be 2 only. 4 by 2, it will again be 2 only. Plus C 10, comma 2, 4, 5. So here I am doing the maximum of it. Plus, uh, this is S QRT, so I am finding out the square root. So it is C 14, 7, 2, 23. So it will be as it is, minus minimum of these three. So it will be minus 2. Okay. So here this is a bracket. So first of all, I'll solve this. So minimum of this will be minus 2. So it will be minus 2 here. Okay. And this is divided by absolute of C comma 2, C2 comma 1. So it is 2 comma 1. Yeah. So then I will have this thing first one. So it is maximum of so if I add these two and subtract this, what I get? 15 plus 10, 25 minus 2 is 23, and 2 minus 2 plus 2, so it is 2 again. Now this vector will repeat itself. So 7 plus 4, 11 minus 2, 9. 9 plus 5, 14 minus 2, 12. So maximum of this will come SQRT of. So it is C 14, 7 to 23. This is plus 2 by C 2 comma 1. Okay, and we are using this. So we'll perform the division first, but I'm not sure that 2 divided by C21 will give you what. So it is basically dividing the second 2 by 2 it is giving, then it is 2 by 1 is happening. So basically this vector, this first vector is repeating itself. So 2 by 2 will happen, then 2 by 1 will happen. So it is 1 comma 2. Okay, so just I'll write it here only. So it will be C1 comma 2. Fine, then we'll add these two and we have to find out the square root. So maximum of this is 23, okay, plus SQRT of this 14 plus 1 is 15, comma 7 plus 2 is 9. Then again it will repeat. So 2 plus 1 is 3 and 23 plus 2 is 25. Okay. Then SQRT function will do what? So it will find out the square root of everything and we'll add 23 to it. So this is not possible for me to find out the square root of these things manually. So you can just do it in R, okay? So 23 plus square root of 15 will be something. Okay, square root of 9 is 3, square root of 3 is 1 point something, square root of 25 is 5, then we'll get the answer for it. So let me show that to you in R. So I've written that also. What is happening? So here I've given the code for it. So yeah, this was the. So I hope it is correct. C15 minus C24 by C212 C10245. The square root of this minus. Okay. So actually I have here skipped one bracket, I think. Yeah. So actually what I have done, so here I have taken this SQRT here as a whole bracket. So just let me change it once. Oh God, got signed out. Just give me a minute. Yeah. So here actually what is happening, SQRT, this bracket is closed here only and we are dividing it by absolute thing. So here what, only I need to change one thing. Okay. I'll just remove this bracket. I've just not added actually one bracket here. So here I'll change it actually. So here it will be. Now they are same. Yeah. So have I done some mistake here in the calculation? You just see it, otherwise I'll see the code actually because it is coming a little different. So it is coming like 25, 26, 24, 28. So is there some mistake? Yeah, yeah, I got it. So here, yeah, now I'm getting this thing. So 26.8, 26.24.7 and 28.28 only. Because at second and fourth position, I'm having this to be 3 and this to be 5. So 5 plus 23 will be 8 and 3 plus 23 will be 26 actually. And at first and third position, I'm getting a decimal. So actually here in the code, I have not included one of the bracket. I have included it here in place of here, but in here I have included that bracket in a different way. That's why the difference was coming, but now it's fine. So because this command and the code was different, that's why it was coming different. Now I have make the changes, and I think now it is fine. So is it fine with you? Yeah, yeah, okay. So I think you got the idea that how to use the BODMAS rule and the functions. Fine. Now we will move towards the matrix. This is a simple like command you have to write to obtain this matrix and this matrix. So now this I'm not doing. I have given you the syntax. Just tell me what will be the command used to obtain this first matrix. And also you can see that the numbers are consecutive 7, 8, 9, 10, 11. So you don't need to write all the numbers on the data vectors. You can write that column thing which I have told you. Okay, so just write the command in the chat box to obtain this first matrix. So how to obtain this matrix? So how to get this first matrix? Write the R code for it. Yeah, so for this I have this matrix command. So inside the matrix, at the first place, I'll write the row numbers. So that is n row to be equals to how many rows I have? 1, 2, 3, 4. So n row to be 4, n call to be 1, 2, 3, 4, 5, 6. And the numbers are from 7 to 30. So I can write 7 to 30 and I'll get this matrix. Okay. Now here and here. So by default, it is getting the numbers are getting added column wise. So I'm getting 7, 8, then 9, then 10. Then if I want to add these number row wise like this. So these are the same matrices. Okay, I'm just adding the numbers row wise here 7, 8, 9, 10, 11, 12. So for that, if I want to write the code, then what I need to include just that I will write the same command matrix and row to be 4 and call to be 6. Yeah, so I'll write the by row to be equals to true. So by row is equals to true, or you can write true the whole in capitals, or you can write only t, it's fine. So you will get this matrix for this. Yeah. So fine. Now we'll just work with some of the logical operators. Sorry, this, yeah, logical operators, where we want to compare two numbers. Okay. So here I have x to be equals to 25, and I want these things to execute and give me the answer. So this is the or command. This is the and command. So if I have true and true, then it will be true, and if any one of it is false, then it will give me false. If and there is and for the or, the rule is that if any one of them is true, then the answer will be true. Okay, so for and, both of them to be true for the answer to be true, but for the or, any one of them, if it is true, then the answer will be true. Okay, so here this is for the or and this is for the and. Fine. So here x is 25, so x is less than 23, so is it true or false? So it is false, because x is greater than 23, so it is false. Here the or operation is there. X is greater than 55, so is x greater than 55? No, so it will also be false. And x is less than 25, is x less than 25? No, so it is also false. And x is greater than 22? Yes, x is greater than 22, that is 25, so it will be true. Or x is equals to 50, so is x equals to 50? No, so it is false. So now we'll operate from the left hand side. False or false, so it will be false. And false and true or false. Now false and false, it will be false. Fine. And true or false. False and true, it is again false and or false. False or false, it will give me false. So answer will be false. Yeah. And for the second one, so you should just maintain it. Don't do like, okay, I have taken false here, and then I'm just doing it. So this is it is like a more cleaner way to write it, in order to not get confused that which will be displayed. Okay. Now apart from this, we have this question. So here x is greater than 6 and x is less than 5. So is it true? So x is 7. So x is greater than 6. So it is true. And x is less than 9. Yes, it is also true. So true and true, it will give me true. Fine. So any doubt in this operators? So now I have many more options. Questions. So yeah, so this is again, I have x to be a data vector 13 to 28. Fine. Now here it is saying, so here I have 13 14 till 28. Fine, I have this data vector x. Now x such that x is greater than 22. So what basically this command means, that I want those elements of x which are greater than 22. Okay, so this command basically means that I want those numbers or those elements of the data vector x which are greater than 22. So what it will display? So it will give you the output 23, 24, 25, 26, 27, 28. So this is the way to get the elements from a data vector which are greater than 22 or any number which you specify. Fine. Now just do this question, fourth one. So I have done 3 questions of different types. I want this fourth question to be done by you. So what will be the output for this? Nine 16. Okay. So I've got the one answer, 9 16. One more answer.
Same 9 and 16.
Fine. So here I have what is the uh, command here, first of all, x such that this condition. So what basically this condition is saying, x such that sorry, the x greater than 2 and x less than 5. So I want those numbers of x which are greater than 2 and less than 5. So greater than 2 are 3 4 5, less than 5 are 3 4. So I'll get 3 comma 4. Okay. Now x 3 comma 4 means the numbers which are present at 3 and 4, so which are 3 comma 4 only, star star 2, so which will give me 9 16. Fine. Okay, so one thing, so I want x so that x is greater than 2 and less than 5. So I should write it here only 3 or 4, not this thing. So this is this has a different meaning actually. So here it will be 3 comma 4. So basically this condition give you 3 comma 4. This condition will give you 3 comma 4, and I want x such that x is greater than 2 and less than 5. So I will get 3 comma 4 here, and star 2 will be this, because the thing which I have written previously has a different meaning. Okay, so that's why I'm not writing that way. So this is 3 comma 4. Fine. What about the fifth one? So x not equals to y. So x is this vector, y is this vector. X not equals to y, I want. So it will give me the answers in true and false. So the first argument will be compared with the first one. So I have the comparison to be done as not equals to. So 15 not equals to 45. True. It will give me true. 18 not equals to 15. It is also true. 20 not equals to 18. It is also true. 25 not equals to 29. This is also true. 16 not equals to 30. This is also true. So it will give me answers as true, true 5 times. So this was about the logical operators. How do we compare two numbers? And there are many more also. So these I've discussed. Okay. Now, fine. Now I will be dealing with the data vectors which have missing values. Fine. So now this is a data vector x which have two missing values at fourth and sixth position. Fine. Now I want to write a command to add numerical entries of the data vector by 5. So I want to add the numerical entries 5. I want to add numerical entries. I want to add a digit 5 to the numerical entries and want to get that output. So just tell me once that if I want to add 5 to each entry here in the data vector, then do I need that na.rm command or not? I want each entry to be added by 5. See, there are two things. Okay, so here I have a data vector which contains this entry na. I want to add it by 5. So if I do this x plus 5 also now, then it will give me the value 7, 8, 9, then na it will give me, then it will give me 10, then na it will give me, then 8 plus 5, so it is 13. So it will basically give me this. So the entries will get added to it. Okay. Just a minute. So am I audible to you? Okay, okay. So I got actually, yeah, fine. Okay. So yeah, so it will get added to each element, each entry. For that, I do not need na.rm to be true, because see here I have so here I have this vector x. Fine, x is stored, and if I do x plus 5, then it will give me this way. So numerical entries will get added to 5, and na will be na only. Okay. But now if I want the sum function to be operated on x, so I want to find the sum of these entries, these numerical entries, and if I do sum x, then it will give me NA. If I want mean x, then it will give me NA. So it will not be like for this function to be executed, these two functions or other functions to be executed, I need, because error is not shown, because NA plus NA, if you add something on in NA, okay, then it will become NA. So the NA will be same because I'm just adding 5. But if I want to include this data vector in a function, and I want to operate that function on it, then basically what will happen, the sum function will add all those entries, mean function will add all these entries and find out the average, then the NA will make all these things to be NA. That's why there's a problem. So then for that you have to write sum x NA dot rm to be true. And same for the mean, you have to write mean x and NA dot rm to be true. Fine. Then it will not give you the error, or it will not give you the NA, it will give you the sum of these entries 2, 3, 4, and 8, and 5 also. I hope this is clear. Is this clear? Any doubt, anything? Yeah, practically NA is the missing data. Yeah, it is the missing data. So if there is some missing data in a data vector, so we have 1,000 and 5,000 length data vector, and if there are some NA quantities, there is some missing data, then we basically, like, we do not have, then we just replace it by NA. Practically, we are NA means is the missing data. So it is there, but it is missing. So for example, I want to collect the heights of the for example, I want to, in a particular place, I want to collect all the heights of the people present there or living there, and in the process of collection of that data, maybe some quantities are some heights are missing, then that data will be missing data. So for a data, so for a first of all you have to uh, so for example, if you want a data vector, then you can just you have to create that as a data vector first of all. If you want uh, for any data vector, you have to give value to each point, okay? And if you want an empty data vector, so I'm also just trying it first time. So it is sorry, is x to be numeric s dot numeric. So for example, if I'm saying it s dot numeric 10, for example, so basically I'm saying that x is a data vector of length 10. Just a minute. Fine. So what basically x is? Okay, wait a minute. So here what is basically is happening? Let me try it once. Okay, x. Fine. So actually, what I have done here, I'm saying x to be s dot numeric 10. So basically, x is I'm creating a vector which is of length 10 here, but I'm not giving any value. But first of all, whenever I have given, so it has the flexibility. This data vector x has a flexibility that it can take multiple values. When I said I want to display x, then it give me 10. Then what I've done, taken I have just assigned the value 5 to the at second place. Then I have a data vector x to be 10 comma 5. Then what I have done, I have given x to be na, and then I say that what is x, then it is giving me na. Then I'm checking that at fifth position of this x data vector what is there, then it is na. So basically it is giving me that at every position now it is na. Now let me check for 10th position. So 10th position I'm able to write means it is a data vector. So it is giving me an A. Let me write it as 13th position, or it is also giving me an A. So now it is a data vector only wherever. So basically here now I write X. So it will give me, it is giving me NA only. Okay. If I write Y, R, M, so I'm removing Y first. Then if I write Y, so Y is not found. But if I'm giving this to be is, so I don't think so that you can create a data vector which each entry is NA. Like you want a data vector where each entry is NA. So what you can do that create a data vector and just give like Y, for example, the length of the data vector is 100. So you can just give Y1 to 100 and just give each value to be NA. If you have a Y as a data vector, some data vector, for example, and just give at each position, just give the value NA, then it will be NA at each position. I think that will be the solution for it. Here in this way. Are you getting what I'm trying to say? So if you have a data vector, for example, X, even take just for M, for example, just give that whatever length you want, you just give 1 to 100 and just assign an A to it. Then it will give you a 100 length data vector, which, okay, what you meant, let me see. So you are saying that if missing, to get a value, to get the value of missing, may get value NA as a value assigned to a position of empty or missing data. So I'm not getting actually what you are trying to say. So actually I'm not clear with your question. So what are you trying to ask? So NA is not a practical value actually. So basically the data is entered so by us only the data will be entered in an Excel sheet. From the Excel sheet only it will be transferred to R. So if in a practical scenario, if you have some missing value, then you will be entering that value to R. So whenever you are entering, you know that at which position there is a missing value, and at that position you will just assign NA to it. or the meaning of NA is basically the missing values. So whenever there is a missing value, it will get assigned by NA. However, so the data is basically entered by us only, or whenever we are taking a data from somewhere, so there are missing values, then this NA is kind of used at the places that some at some points the positions of a vector is also in necessary. Yeah, for the position, I think. Yeah, because at this position, when the position matters, okay, at this position there is some missing value. So basically, what is the so if there is a missing value in the data, so there are many methods to deal with it. So in some way, for example, whenever we are using na.rm to be true, so at that what we are basically doing, we are just neglecting the missing values. In some of the methods, what they do, they are just taking that, okay, fine, which values are missing, and maybe using the position or using something else theory, there is a practical way or there is a mathematical way to find out or to estimate those values, and just use those estimated values in place of NA. So there are methods for those things also. So by using the data present before it, data present after it, so by using those things, maybe someone can estimate that what is the value, what may be the value present here, and use those values here. By using the na.rm, just we are neglecting those values, so there is no use for that. We are basically making our data small by eliminating those values. But if somewhere some problems like some problems is there where we do not want to eliminate those values, we want to first estimate those values, then using those values find the inference about some data. Maybe for that, position is maybe a major for example, if I'm taking height, okay, then position may not be a factor, but for some other data, position may be a factor. Like if you are denoting the position by number of hours, for example, then the position play a very important role. So it is in that way. Is it fine? Yeah. So now just I want this pattern, okay, in R, these three patterns, using the wrap command. Okay, so we have studied this wrap command. So just tell me the commands, the whole syntax by which I can get this pattern. This all I already discussed. This pattern also I have discussed. This pattern. So just tell me the for all three. Just tell me the command by which I can get the first, second, and third pattern. Okay. So obviously wrap will be there. So what will be inside it? So in the first pattern, you can see that we have only three values, 1, 2, 3, which is again and again getting repeated. So the whole vector is getting repeated. Okay. So at the first position, yeah, so it is correct. So if I write 1, 2, 3, so this is the vector which is getting repeated 5 times. So times is equals to 5 here. Fine. But at the second pattern, there are 4 values now, 1, 2, 3, 4, but each is getting repeated 3 times. So here I can write the data vector to be 1, 2, 3, 4, but each is getting repeated. So I have to write each to be equals to how many times? 3 times. So it is 3. Fine. Now just tell me for the last one. For this pattern, what I should write. I want first to be repeated 1 times, second two to be repeated 2 times, 3 to be repeated 3 times, 4 to be repeated 4 times, and similarly so on till 10. So there is no doubt that data vector will be 1 to 10. Okay. And I want 1 to be repeated 1 time, 2 to be repeated 2 times, 3 to be repeated 3 times. So here again also I will write 1 to 10. So what will happen? 1 will repeat 1 time, 2 will repeat the second entry 2 times, 3 will repeat again 3 times, 10 will repeat 10 times. So it will give me this pattern. So is it fine? Is it fine? Is this question fine? I don't think so. What you've written, what does it mean when you are writing C and inside C you are writing n is equals to 1 to 10? So this is what did this will give you? I don't think so. This is a correct way to write. So you are right combining what? C n is equals to 1 to 10. I'm not getting that what you are trying to do with that, because whenever you are using C, so basically you want to combine numbers, or you want to combine two data vectors. But here inside C you are taking n is equals to 1 to 10. I don't think so it is correct. Yeah, so you have to use this command. I think this will work. So this is rep, and at the first place you are using 1 to 10 because you want that data vector. And the second place, basically the data vector is giving you that first position 1 time, second position 2 times. So this is a way to write it. No, times is not equals to each actually. Each means that each value will be repeated 3 times. Times means that the whole data vector is repeating 5 times. But what basically this data vector here is doing, so by default it is times only. Okay, so whenever I'm using rep, by default it is times. So if I don't write times, I write just 5. So basically it will repeat this data vector 5 times. Okay, for each I have to write each. So basically here it is saying that here also it is a data vector, here also. So whenever it is taking as 1 to repeat the number which is present at 1 first position, second to repeat the number of times which is the number present at second position, which is 2 for the second data vector, and similarly it is happening. Yeah. So now this is the last question for this session. So I want to create this data frame. Okay, so here I have name, column name to be name, age, marks. Fine. So I want to create this data frame. So what will be the syntax for it basically? So here I can add df. I'm naming the data frame to be df. So it will be data dot frame. So this is the syntax for a data frame. Fine. Now data dot frame. The first column is name. So I'll write name. Okay, is equals to C. And what are the, that's why I'm taking it as in double quotes, Sunita and Rajesh. Fine. Now the second one is age. So age to be C, 21, 20, 22. Then I want marks equals to C. What is the data vector? 85, 90, 78. So this is the command. This will create a data frame df. Okay, let me show you this data frame. So here I have this data frame. I have okay, so how this data frame look like? So now this is the data frame. Fine. Now I want you to extract the age column from the data frame. So now this is the data frame df, and I want the age column to be extracted. The name of the data frame is df, and I want age column to be extracted. What will be the command for it? I want the age column from the data frame. So what will be the command to extract age column from the data frame df? So it will be df dollar age. Yeah, that's fine. Okay, I want to extract the second row from the data frame. So this is the second row. This is the second row. I want to extract this second row. So how will I extract it? Second row actually, not the second column. So the age already we extracted. I want this second row now. So basically the second row, how will I do that? So I will write df as it is. Okay, I want second row. So at the row place I will write 2 and the column place I will leave it empty. So it will be d2 comma empty place. So let me show you that. So so the age thing, so it is giving me the age column 20, 20, 21, 22, 20, 21, 20 and 22, and the second row, so this is df, and second row comma this is empty. So this is giving me the second row. Yeah, that is a matrix concept only. Yeah. So if there are, if so we have not given the names to the rows actually. So if we give the names to the rows also, then we can also extract the rows by using this dollar thing. Okay, so if I give name something, so I do not want to go in that detail. So if give you will give names to different rows, then you have to write the row names and give the names, and then you can extract those rows using those names by using this dollar thing. Otherwise, you can extract it using this matrix concept also. Okay, now in the next question, I want to extract all students with marks greater than 30. Okay, so I want to extract all students with marks greater than 80. So what I will do? Which command will I be using for that? DF, the DF is greater than 30, 80. You cannot, I don't think so. I don't think so. So let me check it. Because here, whenever you are comparing this DF is greater than 80, where you are comparing a data frame with, I don't know. No, it is not giving me the correct output actually. Because I want marks to be greater than 80, I want to display all those students whose marks are greater than 80. Now for that, I want these two students, which is Anita and Sunita. Anil and Sunita, sorry. Not Rajesh. But here the output is like weird. So it is taking some else. It is giving something else. So it is of course not giving 2278 this thing, but it is giving Rajesh, means that this is giving this Rajesh, which is not, I think, correct way. So for that you just use this subset command actually. So this is used, subset is used for this data frames. So subset df comma, where you have to specify that which thing you want greater than 80. So I want marks to be greater than 80. So here if I do that, so it will give you the whole thing, the data frame you are giving. You are only neglecting those students from a data frame which have marks greater than which have marks less than 80. Otherwise you are giving the information for all other students. And also this subset is again a data frame only. Here this is not a data frame actually. This is a data vector now. Here df greater than 80, so this is a data vector now. But here after this subset I'm getting a data frame only. So I'm getting a sub. So for example, if I'm getting a sub matrix from a matrix, so the submatrix is again a type of matrix only. It is not a data vector. So here by using subset, I'm getting a data frame only, not a data vector. So it is basically what? Subset BF and marks greater than 80. Fine. So I think this is all for today's session from my side. And now the recording for this today's session will be uploaded on YouTube on the link which I have provided here in the chat box also, and in the slides also. And the PPTs and the R script which I've discussed today will be added on the Google Drive. And the deadline for your assignment is 4th February, and our next session will be on 2nd Feb. Fine, from 6 to 8 p.m. Now, if anyone have any doubt, then you may ask. This was a long session. I'll try to keep a little the questions to be little short or the other things. So if anyone has some suggestion, then please like you can give your suggestions for holding these live sessions, and also if anyone have any doubt, then you may ask. So how was the session? Okay. Okay, thank you very much. So if yeah, you may leave. If you do not have any doubt, or if you are fine, if everything is fine, then you can leave. Okay, fine. So if you people have any kind of suggestion, then please just let me know whatever you want to get, like add in this. If I need to add something in this live session or something like that, you may just tell me. In the next sessions also, we'll be discussing other things. So yeah, uh, fine. So we'll end this session if there is no more questions or something. And you may leave. You may leave. Thank you very much for joining.